Hello everyone. In this video, we're gonna learn how to solve exponential and logarithmic equations work problems. Modeling with an exponential equations. Now we have the exponential function formula. It's gonna be f of s equals a times b raised to the s. Alright, this guy is the same thing as a times 1 plus r raised to the s. Alright, if r is greater than 0, this equals root great. And then 1 plus r b. This guy is called the growth factor. Now, if r is less than 0, this is called decay rate. And b equals 1 minus r is called decay factor. Alright, so keep that in mind. Now, we need to summarize the problem. Alright, so we have a is the initial value. And f of s is the ending value. So the ending value is f of t is 600,000, right? Because it is half of the trees, so the initial value is 1,200,000 trees, right? Now we look at this one, we see that we have a 7% of the tree each year, right? Which means the number of trees is reducing every single year, right? So the R right here is called decay rate because it's going to be negative. So R is negative 7%. So it's going to be negative 0.07, right? And then B in this situation it's going to be 1 minus 0.07, which is 0.93, right? And then you have the formula f of t equals a times b raised to the power of t, right? And then you just substitute the value, right? F of t is going to be 600,000 equals 1,200,000 times 0.93 raised to the t. Now we need to solve for t, so we need to divide both sides by 1,200,000, right? So it's going to be 1.5 equals 0.93t. Or you just rewrite this one as 0.93 power of t equals 1/2, right? Now you just take natural log both sides, so natural log of 0.93 power of t equals natural log of 1/2, right? So net 1/2, which means 0.5, so I just put natural log of 0.5. Alright, so t you can bring to the front, so it can be t equals natural log of 0.5 divided by natural log of 0.93. Alright, so you just hit the calculator, the answer must be approximately 9.55, right? So it will take about 9.55 years to harvest half of the original trees. Alright, let's move on to the next example. Modeling with an exponential equation in finance. A saving bond earns interest at a rate of 5.5% if the saving bond is purchased for $600. How long will it take for the value to double if the interest is compounded, right? So we have the formula. A equals P times 1 plus R over N raised to the T times N. Now A is the balance or ending amount. P is the principal or the deposit or the initial amount. R is the annual interest rate. R is the annual interest rate and will be expressed as a decimal. N is the number of times interest is compounded per year. And T is the time in year. Now, in order to apply this formula, you need to understand that annually, which means N equals 1. Quarterly, which means N equals 4. Monthly, which means N equals 12. And continuously, we need to apply the formula A equals P times e to the r times t, because this is continuously. Alright, so question A, annually. So we have A equals P times 1 plus R over N raised to the T times N. Now N equals 1, so you just substitute. It's going to be the ending amount is double the initial amount, right? So it's going to be 1200 equals 600 times 1 plus 0.055 over N equals 1, so we put 1 right here, raised to the T times 1. Alright, so we just simplify this one. It turns out to be, divide both sides by 600, it's going to be 2 equals 1 plus 0.055, it's going to be 1.055 raised to the T, right? And then this guy is the same thing as 1.055 raised to the T equals 2. And then we just take natural log both sides, so it could be natural log of 1.055 raised to the T equals natural log of 2. Alright, so T we can print to the front, so it turns out to be T times natural log of 1.055 equals natural log of 2. And then T equals natural log of 2 divided by natural log of 1.055. Now we're going to bring up the calculator. So we hit control natural log of 2 divided by control natural log of 1.055 and hit enter. So the answer is 12.9462. Now question B, quarterly, which means N equals 4, because we have 4 quarters per year. So we have 1200 equals 600 times 1 plus 0.055 divided by 4. Altogether raised to the T times 4. Alright, so this guy turns out to be 2 equals, we print up the calculator, so we hit 1 plus 0.055 divided by 4. Hit enter, the answer is 1.01375, right? So it could be 1.01375 raised to the 4t. And then we're gonna take natural log both sides, right? So we have natural log of 1.01375 raised to the 4t equals natural log of 2. And then we bring 4t to the front, so it will be 4t natural log of 1.01375 equals natural log of 2. So t equals natural log of 2 divided by 4 times natural log of 1.01375. And then we bring up the calculator. It's going to be natural log of 2 divided by parentheses 4 times natural log of 1.01375 close parentheses. Hit enter. So the answer is 12.69, right? So it could be approximately 12.69 years. Now let's move on to question C. Is n equals 12 because we have 12 months per year. So it's going to be 1200 equals 600 times 1 plus 0.055 divided by 12 raised to the t times 12, right? Then it's going to be 2 equals, now 1 plus 0.055 divided by 12. It's going to be 1.00458 raised to the 12t, right? And then take natural log both sides, so it could be natural log of 1.00458 raised to the 12t equals natural log of 2. And then bring 12t to the front. It's going to be natural log of 1.00458 equals natural log of 2. And then divide both sides by, so t equals natural log of 2 divided by 12 times natural log of 1.00458. And then we're going to print up the calculator. So it's going to be natural log of 2 divided by 12 times natural log of 1.00458 and hit enter. It's going to be 12.64, right? 12.64 years. Let's move on to the last one. We're going to use this formula. So we have A equals P times E to the R times T, right? So A equals 1200 equals 600 times E raised to the 0.055 times T, right? So divide both sides by 600, so it's going to be E to the 0.055 T equals 2, right? And then take natural log both sides. So I have natural log of e to the 0.055 t equals natural log of 2. Alright, so I can bring this guy to the front, right? So it could be 0.055 t natural log of e equals natural log of 2. Now natural log of e equals 1, right? So this one gone, right? So you have t equals natural log of 2 divided by 0.055, and then you hit the calculator. Natural log of 2 divided by 0.055. Hit enter. So it's going to be 12.6 years. Now let's move on to the next example. Modeling with logarithmic equations. The enrollment at the private school was initially 120 students and has been increasing by about 30% each year. Formulate a logarithmic function t of s that approximates the number of years t it will take before the enrollment reaches s students. Right, so we have the function f of s is a times 1 plus r raised to the s. Right, so in this situation the variable is t, right? So just write f of t equals a times 1 plus r raised to the t, right? Now this guy right here is called b, right? b is called the growth or decay factor, right? Now depends on r. If r is positive, this is called growth factor. If r is negative, this is called decay factor. R is called growth rate or decay rate. If we look at this one, we see that s right here is the function of t. So we just change this one into s of t. Alright, so we see that the number of students has been increasing by about 30% each year. So this guy tells us that R is the growth rate, right? Because it's positive, it's increasing, right? So I use the formula right here. So I have S of t equals initial amount, which means 120 students, times 1 plus, this guy must be decimal, so it could be 0.3 raised to the t. So I just simplify this one, it turns out to be 120 times 1.3 raised to the t, right? And this is the exponential function with respect to t, right? Now question asks us to find the logarithmic function t of s, right? So I have s equals 120 times 1.3 raised to the t. Now I need to convert this exponential function into the logarithmic function, right? So basically I just take log base 10 both sides, right? So I have log s equals log 120 times 1.3 raised to the t. Now I need to apply the product formula of the log to split this one into the addition, right? So I have log s equals log 120 plus log 1.3 raised to the t, right? Now t right here I can bring to the front, right? So it's gonna be log s equals log 120 plus t log 1.3, right? Now I need to solve for t. Then I need to subtract log 120 both sides. So I have t log 1.3 equals log s minus log 120, right? Now I need to divide both sides by log 1.3, right? So t equals log s minus log 120 divided by log 1.3. This is the function with respect to s that approximates the number of years t required to reach an enrollment of S students. Now here's the problem for you to practice. Alright, this question is slightly different from the previous question because you have this one, right? This is triple. Now you have half year, you have weekly, you have daily, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.